Have you ever really thought about what happens to the food you eat? I mean, after you've enjoyed it? Today, we're diving deep into the body's metabolic engine room. We're going to meet the unsung heroes that turn our meals into energy: the liver, pancreas, and gallbladder.
So, let's start with a question. What could your liver, your pancreas, and a simple sugar cube possibly have in common? Well, it turns out they're all major players in your body's amazing energy management system. From the second that sugar touches your tongue, these organs kick into gear, working together perfectly to turn it into fuel, store some for later, and clean up all the waste. It's this incredibly complex, high-stakes dance that's happening inside you every single second.
All right, first up, let's talk about the undisputed heavyweight champion of metabolism, the liver. And honestly, you should think of it less like just an organ and more like your body's main chemical factory and central command all rolled into one.
I mean, the sheer number of jobs the liver has is just staggering. It's this incredible multitasking powerhouse. It processes every single nutrient you eat. It neutralizes toxins. It makes bile for digestion. It manufactures essential proteins. It even creates clotting factors and stores vitamins. It really is your body's mission control.
Okay, let's zoom in on just one of those critical proteins, albumin. This molecule, which is only made by the liver, basically acts like a powerful sponge. Its job is to keep fluid where it's supposed to be, inside your blood vessels. So, when the liver's factory starts to fail, albumin levels drop. And what happens? That fluid can start leaking out, causing swelling. That's exactly why a low albumin level is such a huge red flag for doctors looking at chronic liver disease.
Next up, bilirubin. This is a yellow pigment that comes from old, broken-down red blood cells. A healthy liver is great at grabbing it, processing it, and then getting rid of it through bile. But if the liver's damaged, or maybe the bile ducts are blocked, bilirubin starts to build up in the blood, and that leads to jaundice, that telltale yellowing of the skin and eyes.
One of the liver's most vital jobs is to constantly filter your blood. It's always pulling out harmful stuff like ammonia, which is just a natural byproduct of digesting protein. So you can really think of it as your body's own high-tech water purification system.
So what happens when that super sophisticated filter gets clogged and just stops working? Well, the consequences can be absolutely devastating, especially for your brain.
This is a condition called hepatic encephalopathy. When the liver fails, ammonia doesn't get filtered out. It just builds up to toxic levels in the bloodstream and then crosses right into the brain. This can cause some really serious issues: confusion, major personality changes, and a very specific symptom called asterixis. It's this flapping tremor you can actually see when someone holds their hands out. In the worst cases, it can even lead to a coma.
Now, it's so important to remember that these organs don't work in a vacuum. A problem in one can set off this dangerous chain reaction in its neighbor, and this is exactly what can happen with the gallbladder and the pancreas. It's like a domino effect of disaster.
It often all starts with gallstones. These are basically just hardened little deposits, usually made of cholesterol, that form inside your gallbladder. For a lot of people, they just sit there and don't cause any problems. But they absolutely have the potential to create some serious trouble down the road.
And there's a classic little mnemonic to help you remember the main risk factors, the 4 Fs. That's female, fat, 40, and fertile. So why these 4? Well, hormones like estrogen, which are higher in women and especially during pregnancy, can actually increase the cholesterol in your bile, and that makes gallstones much more likely to form. It's why these factors are so important to know about.
So here is that domino effect in action. Let's say a gallstone moves out and blocks the main duct that it shares with the pancreas. Suddenly, you've got a traffic jam. Powerful digestive enzymes from the pancreas get trapped, and they activate while they are still inside the pancreas. The result is, frankly, horrifying. The pancreas literally starts to digest itself. It's a process called autodigestion, and it causes massive, massive inflammation and just excruciating pain.
Now, the pancreas isn't just about digestion. It has another, much more famous job: regulating your blood sugar. And when this system fails, it leads to diabetes. But it's so crucial to understand that diabetes isn't just one single disease.
The two main types of diabetes are completely different beasts. With type 1, the body's own immune system attacks and destroys the cells in the pancreas that make insulin. So it's a production problem. There's simply no insulin being made. In type 2, the body's cells become resistant to insulin's effects. The pancreas tries to make more to compensate, but eventually it just can't keep up. This is a problem of reception,
totally different mechanisms. So, in both types of diabetes, if things aren't well controlled, blood sugar can spiral to dangerously high levels, and that can trigger some really life-threatening medical emergencies.
So what exactly happens when that system is just completely overwhelmed? The body is forced into the state of metabolic chaos, and that leads to two very distinct but equally dangerous crises.
This brings us to DKA and HHS. On the left, we have DKA, or diabetic ketoacidosis. You typically see this in type 1 diabetes. With no insulin at all, the body starts burning fat for fuel, which produces these acidic things called ketones that basically poison the blood. On the right, we have HHS. This is more common in type 2. Here, there's just enough insulin to stop that acid from building up, but not nearly enough to control the sugar. So blood glucose levels skyrocket, causing profound dehydration. The number one thing to remember is this. DKA is all about the acid, while HHS is all about extreme dehydration.
Okay, so with all these serious potential complications, how do we keep this incredibly intricate metabolic engine running smoothly? How do we prevent these crises from ever happening in the first place?
Well, this brings us to something called the sick day rules, and this is an absolutely critical action plan, especially for anyone with type 1 diabetes. See, when you get sick, your body releases stress hormones, and those raise your blood sugar. So the three most important rules are, number 1, never, ever stop your insulin, even if you can't eat. Number 2, you have to monitor your blood glucose and check for ketones way more frequently. And number 3, hydrate like crazy to flush everything out. Following these rules can be the difference between a simple cold and a full-blown emergency.
At the end of the day, your liver, gallbladder, and pancreas work together in this delicate, interconnected balance. They form this amazing metabolic engine that is constantly, tirelessly working to power your life. Understanding how they all function and how they can fail is the first step. But the real question isn't just if you're maintaining that engine, it's how. What choices are you making today to keep it running smoothly for a lifetime?